So a few last thoughts here on vectors and planes. This is part 3. So something to think about and try to visualize. If vector u and vector v are perpendicular to planes p and q respectively, what is true if plane p and plane q are perpendicular? So see if you can visualize. I'm going to see if I can draw this. Here is our plane p, and it has vector u coming out of it that is perpendicular to it. And then here is, if you can visualize, plane q, and I'm trying to make q look like it's perpendicular to plane p, and q has a vector v that is perpendicular to it. So hopefully the conclusion you're coming to is that if the planes are perpendicular, then so must be their vectors, the vectors that are perpendicular to them, that is their normal vectors. And so that's really how we're going to decide if the planes are perpendicular, is if their normal vectors are perpendicular. Similarly, if I can draw this, if we have plane P that has vector u again perpendicular to it, and then if we have plane Q that is parallel to plane P and it has a vector v perpendicular to it, hopefully we can see then that the vectors must be parallel as well. And so this works both ways, meaning that we have said if the planes are perpendicular, then the vectors must be perpendicular. Likewise, if their normal vectors are perpendicular, then the planes must be perpendicular as well. And similarly, if the normal vectors to the planes are parallel, that's going to imply then that the planes are going to be parallel to each other as well. Okay, I'm going to go to a new panel and we'll do a little bit of this with some numbers. So here we have some equations of planes. So we're going to try to show that the plane 5x minus 3y plus z equals 10 is perpendicular to x plus y minus 2z equals negative 4. So if the planes are going to be perpendicular, that means their normal vectors must be perpendicular. So our normal vector to the first plane is that ABC, the 5, negative 3, 1. And the normal vector to the second plane is going to be the 1, 1, negative 2. So we can show that if u is perpendicular to v, then the two planes must be perpendicular. Then we can show two vectors are perpendicular if their dot product is 0. So let's see, 5 times 1 plus a negative 3 times 1 plus 1 times negative 2 looks like 5 minus 3 minus 2 equals 0. And so we have shown that they must be perpendicular. Now, going on to part B, to show that the two planes are parallel means we need to show their vectors, their normal vectors, are parallel. So there's our first normal vector to the first plane, and negative 12, 6, negative 9 is the normal vector to the second plane. So to show two vectors are parallel means we have to show that they are multiples of each other. So to do that, I would just pick out one of the components. So can we show that 8 times some number is equal to negative 12? And if we solve that for k, we'll get negative 12 eighths, which is negative 3 halves. So if the other components are that same multiple, then the vectors are multiples of each other. So we can show that negative 4 times 3 halves is equal to negative 6, so that works for there. And similarly, 6 times 3 halves is going to be 9. get that right. It was a negative 3/2. Hold on there. That was supposed to be a negative 3/2 makes that a positive 6, which is a match. And negative 3/2 times 6 is a negative 9, and we have it. So we have shown that vector u is a multiple of vector v. And that means that they're parallel, the vectors are parallel, therefore their planes are parallel. Very good.